So today we will study about the thermodynamics, right? Thermodynamics, Unit 6. So see here, thermo means heat. Dynamics means change. So when heat is applied on any system, right? Suppose this is your system, heat is applied on it, right? Q. So what is the changes on this system that we have to study in the thermodynamics? So it is the only physical theory of the universe constant concerning which I am convinced that within the work frame of the applicability of the base concept, it will never be overthrown, right? So chemical change stored by the molecules can be released as heat during chemical reaction when a fuel like methane, cooking gas, oil burns in it. So chemical change stored by the molecules can be released, right? How it is released? By changing the heat. Chemical energy stored by molecules can be released by applying the heat, right? So next is various form of energy are interrelated and under certain condition. This can be transformed from one form to another form. The study of this energy transformation, the subject matter of thermodynamics, right? So heat is transferred from one form to another form. It can be transferred from one form to another form, right? That is called thermodynamics property, called thermodynamics property, right? Now see the next point. So law of thermodynamics apply only when a system is in equilibrium or move from one equilibrium state to the another state, right? So law of thermodynamics is applicable. Law of thermodynamics is applicable when system is in equilibrium, is in equilibrium, or when it changes from one equilibrium to another equilibrium, or when it changes from one equilibrium to another equilibrium. That time laws of thermodynamics is applicable. Or microscopic properties like pressure, temperature do not change with the time for the system in equilibrium. Right. So next is thermodynamics terms which we will be using in this condition. So next point is thermodynamics terms. So first term is your system. System. So what is system? A system in thermodynamics refer to that part of universe in which observations are made and remaining universe constitutes the surrounding, right? So system is a part of the universe. It is the part of universe that we have taken for the study, that we have taken for thermodynamics study, right? And rest of the part except this one, surrounding, is called surrounding. So next term is surrounding. Remaining universe constitutes its surrounding. So write the terms. Remaining universe constitutes surrounding. Right. The surrounding includes everything other than the system. System and surrounding together constitutes the universe. Right. By adding system and surrounding, what we get? The universe. So universe is the sum of both. Right. So system and universe. System and surrounding is universe. Right here, surrounding. Right. So the entire universe other than the system is not affected by the changing taking place in the system. Therefore, our practical purpose, the surrounding are the part of the remaining universe which can interact with the system. The region of a space in the neighborhood of the system constitutes its surrounding. Right. If you are studying the reaction between A and B kept in a container, the beaker containing the reaction mixture is the system, and room where the beaker is kept its surrounding. So example is given for system and surrounding. Suppose A and B are reacting to form product P. It is kept in a beaker, right? And this beaker is kept in a room, right? So this beaker is your system and room is your surrounding, right? Now see, note that system may be defined by physical boundaries. So how system can be defined? Defined by physical boundaries. Defined by physical boundary. Physical boundaries. Like beaker or test tube, our system may simply be defined by a set of Cartesian coordinates species in a particular volume and space. It is necessary to think of the system as separated from the surrounding by the some sort of wall, which may be real or imaginary. The wall that separates the system from surrounding is called boundary. Now write the definition for boundary. So boundary, it separates the system and surrounding. The wall that separates the system from surrounding is called boundary. This is designed to allow us to control and keep track of all the movement of the system of matter and energy in and out of the system. Control and keep track of all the movement of matter and energy. So what it keep? keep the track of all movement of matter and energy, right, in or out of system. So right up to this point, then we'll do the next part. Now see the next type, that is types of system. Next topic is types of system. So system according to the movement of matter and energy in and out of the system. So how system is classified? Due to the movement of energy and matter. So system is defined as due to the movement and energy in or out of the system, out of the system, right? So now see the next. So how first type of system is your open system. So that is called open system. So let's see the definition of it. In an open system, there is exchange of energy and matter between system and surrounding. So how it is defined? When both can exchange matter and energy. So in an open system, matter and energy both can exchange. Matter and energy both can exchange between system and surrounding. System and surrounding. The presence of reactant in an open container is example of an open system, right? Here the boundary is an imaginary surface enclosing the beaker and the reactant. So what is the example of open system? So the presence of reactant in an open beaker, example of open system. Presence of reactant in an open beaker is an example of open system, right? So you can draw the diagram also. Here is a system. So I will write as a system here. And this is exchanging the energy, right? So energy is nothing but heat plus work. It is also exchanging the matter with the surrounding. So outside this boundary, that is called surrounding. So in open system, this is your open system. Both can be exchanged, right? Matter and energy. Now see the next one is closed system. Next one is closed system. Right. In closed system, there is no exchange of matter, but exchange of energy is possible between system and surrounding. So how closed system is defined? So let's see. So in a closed system. In a closed system, there is no exchange of matter, but exchange of energy can happen only. Exchange of energy, that is called closed system, is possible between system and surrounding. Right. So see the example of it. So the presence of reactant in a closed vessel made of conducting material like copper and steel, example of closed system. So you can draw the diagram for closed system. Right. So we have covered this beaker. This is the reactant which is closed in a beaker. Right. And this wall can conduct the or transfer the energy. Right. There is exchange of energy only. Matter is inside the constant. Matter is constant. That is called closed system. This is the closed system example. Right. Now see the next definition, that is isolated system. Next type is isolated system. So in an isolated system, there is no exchange of energy and matter between the system and surroundings. In an isolated system, there is no exchange of energy and matter between the system and surrounding, between system and surroundings. Right. So you can see the diagram for that. So upper part will be the non-conductor. So system which is made up of non-conducting material. So matter is inside and energy is also inside. It is no exchange with the surrounding. The presence of reactant in a thermos flask or any closed insulated vessel, example of isolated system. So its example is thermo flask, and insulated vessel, right? That is called isolated system. So right up to this point, then we'll move ahead. Next is state of system. State must be described in order to make any useful calculation by specifying the quantitatively each of the properties such as pressure, volume, temperature, as well as composition of the system. So in a state of the system, what will be counted? Pressure, volume, temperature, right? So these comes under the properties of the states of the system, as well as composition of the system also, as well as composition of system, that comes under the state of system. We need to describe the system by specifying it before and after the change. So we will recall from our physics course that the state of a system in mechanics is completely specified at a given instant of time by the position velocity of each mass of the system. In thermodynamics, a different and much simpler concept of the state of system is introduced. It do not need detailed knowledge of motion of each particle because it deals with the average measurable properties of the system. State of the system by state function or state variable. So a state of the system is also called as a state function and a state variable. So next point is the same point is called state function. State function. Next one is state variable. State variable. Right. The state of a thermodynamic system is designed by its measurable or microscopic properties. So how to measure it? The state of thermodynamic system is described by measurable and microscopic properties. State of thermodynamic system is described by measurable or microscopic properties. That is pressure, volume, temperature, and moles. Moles means amount. Variable like pressure, temperature are called a state variable and a state functions. So these are called state function and state variable. Because of their value depends only on the state of the system, not on how it is reached. So why it is called state function? It depends on the state only. Depends on a state, not on how it is taken out. How the path it follow. Right. So it depends on the initial and final position only. This number depends on the nature of the system. Once this minimum number of microscopic properties are fixed, other automatically have definite value. The state of surrounding can never be completed as specified. Fortunately, it is not necessary to do so. So right up to this point first. Next is internal energy as a state function. Right. So when we talk about our chemical system losing or gaining energy, we need to introduce a quantitative which represents the total energy of the system. Right. So in chemical and electrical and mechanical or any other type of energy, you may think of the sum of all the energy of the system. In the thermodynamics, we call it as the internal energy of the system. Right. So losing and gaining the energy is called here internal energy. Losing and gaining of system is called internal energy. Internal energy of the system. It is represented by U later. So heat passes in and out of the system. So when it changes, or it may change when heat passes into or out of the system. Out of the system. Next is work is done on or by the system. Work is done on or by the system. Next is matter enters and leaves the system. Matter enter and leaves the system. Right? These systems are classified accordingly. So, who decides the change in internal energy? These three quantities. Heat pass in and out, work is done, or matter in and leaving the system. That defines the internal energy. Then we'll do the next in the next class. So that's all for today. We'll meet tomorrow.